The bus is straight outside the hotel there. Okay, great. So the first speaker this afternoon is Hugge. He's basically a man who needs no introduction.
I don't know.
Welcome him to the stage.
Thanks.
Hugge.
Oh yeah, we're good. Hi, yes, I'm Hugge, or my real name is Fredrik Korsbäck. I work at a couple of companies. I work with networking primarily, but I also work a lot with manipulating people, I guess. That's where I'm a layer 8 architect. So I did this talk like really yesterday in the middle of the night, and I noticed, just as Ellen said, that there's a lot of new faces here. So I actually had another talk for this first, like a really advanced RPKI talk. But I noticed there was a lot of new people here. So I redid the whole talk and actually going to do BGP edge security for dummies, because I think that is a better alternative than to go deep diving in, for example, RPKI, which is what I would typically talk about when doing conferences this year. And also to celebrate that the EU failed on in Article 11 and 13, this will be presented in the way of memes. So hopefully we can have a few good laughs here after lunch. So we will do BGP security for dummies. And first, we need to ask ourselves, why do we need to care about BGP security? I think most people should be aware that, for example, hijacking, misorientations, and other type of attacks has been much more common these days than before with BGP. BGP is a protocol we use on the internet to exchange routing information. And from history, we kind of just trusted each other and made sure that, yeah, no one is doing anything wrong. So we don't need as much security because we will trust each other. That is not true anymore. We have a lot more players on the internet that is running BGP, that has peerings with each and every one, and which doesn't always have friendly intentions or just simple mistakes. Because even here, if Christian has the most advanced automation in the world, there will still be mistakes made from the ones that doesn't have perfect automation. So these are a couple of cool links. I'm not going to go deep into that, what they are, but hopefully people are aware that this is a problem and it is spreading. In this type of meme here, people probably start out here with almost nothing, no import filters, no export filters, and I'm going to help you through this talk to progress to the last part, which is RPKI origin validation. But there's a few steps you can take along the way to actually come there. And maybe a few of these steps we could actually just stop and be there and be happy about it. So the first, as with any 9 or 12 or 15-step program, you first need to come clean. So am I part of the problem or the solution? And yes, most likely you are. I mean, if you are operating on ASN, which has at least one peer, transit included, you are part of both the problem and the solution. And if you're not, for example, if you sell boxes or transceivers, yeah, then you can probably just go, for example, read up on other memes on honestnetworker.net, which I can recommend, or just go emailing. So step 2 is to do the very, very needful basics. And I have examples here for Juniper and Cisco devices, how you can do this. So I really hope that the slide will be published afterwards, so you can essentially go and just copy-paste everything here. There will be a few commands here which could be useful here. So the first thing you need to do when you start as a new operator, or if you have an operator already and you want to improve something, you should reject bogon ASNs and you should reject bogon prefixes, or Martians as we sometimes call them. So in terms of ASNs, there's a few. Most of them are specified through an RFC why they should be blocked, because they are used for something else. So if you see paths on the internet which has these ASNs, they are mostly malicious paths. So for example, ASPath 0 is not a viable one. We have a couple of, the last 16-bit and 32-bit ASNs. We have documentation ASNs. So all of these can be safely blocked. There has been attacks with, for example, ASPath 0, which has been seen on the internet, which has crashed a few vendor routers. Same if you have an XR-based router. It's the same type of list, but in XR commands instead. So please copy-paste this list and put them in your routers. Then we have bogon prefixes, prefixes which for some reason should not exist on the internet. RC 1918, I guess, is the easy one to spot. 192, 168, 00-16. There's a couple of other ones which shouldn't be possible to route on the internet either. Same goes for v6. There's a couple of documentation, private prefixes, stuff like that. So these are more than safe to just block in your border. And as well as to block from customers unless the customer has some kind of weird demand, for example, in a VRF. Then, of course, this doesn't apply. Yes, and also the prefix one for XR. Okay, step 3. I think that the very needful basics also contain small prefixes. I think most people have this already, but if you don't have it, please fix it. And also, I'm not sure, I think it was Quagga routers. Someone tried to do long AS paths. For example, pad with 100 ASNs. This is very, very easy to do because most people do the whole AS path prepending the wrong way. So they or rather it's the operating system that does this differently. For example, if you put in a number, like prepend my ASN this amount of times, but then it suddenly injects the wrong ASN instead of the actual number of prepends. And this differs a little bit. So rejecting long AS paths is a very good thing, especially if you're running like Quagga, which I think was the operating system that crashed when someone announced long AS paths. Okay. So what we want to do, of course, is we want to accept /24s and bigger, but nothing smaller. We should block on the internet from public peers. So both on Junos and Cisco, this is super, super easy. I mean, you just specify the prefix length. This is coming from my routers directly. So we just block from any edge peer. We block anything that is between /25 and /32. Should be easy, okay? I will not spend a lot of time on these steps because these are the easy ones that I think most people have, but if you don't, then just copy-paste, okay? Long AS pass, the same thing, very easy to do on both Junos and Cisco. Then comes, which I think maybe not everyone has, and that is to use maximum prefix to your advantage. So, you know, having route leaks, having peers announce you, for example, the full BGP table, that I think happens all the time. But most big ISPs hopefully blocks this and kills the session before this happens, or has a filter of some other sort that blocks this type of things. But it still do happen. And you can see these happening even in bigger networks as well, that you have like a full leak of the full table. So using max prefix to your advantage is actually a very effective tool. So this is also from my routers directly. So this is a peer I have with Facebook over Netnod. And they have stated this is also debated, does this value means what you should have as a prefix limit or the amount of prefixes you announce? Since there is no exact science behind this, we always pad up about 10 to 12% on whatever value is stated here. And this is something that we update on every router every night for every peer we have. So it's not a very complex operation. You just through the API go out and pull out this number. And then as we use Cisco NSO in the back. So it has a service that does maximum prefix updates on every peer and make sure that we are always about 10% above what they have. This is to protect ourselves from big leaks. Because it doesn't necessarily need to be a leak which is the full table, but it could be a small leak also, for example. So having a good using maximum prefix to your advantage is a very good thing, which has helped us quite many times. And of course, you get a very good feeling when you kill sessions that is leaking 74,000 prefixes over an IXPs. Okay, then comes one of the bigger ones, which is step 5, which is IRR filtering. So this is something that's been debated and it's been on every single NOG, I think there's the debate or discussion or talk about IRR filtering. And it can be hard to actually understand what it is because people have talked so much about it that it's hard to tell what is actually the truth nowadays. So what we do know about IRR filtering, this will be the super short version, is that it has a lot of inherent problems. Excessive filtering will most likely affect your routers in a negative way. I know that from very good experience that I have a lot of crashed routers due to this. But it's probably still worth it, at least to do some of it. So, what is the problems? So the first problems with IRR filtering is that it's not really authoritative data. It is kind of truth-ish, because there are so many places where you can register IRR data. Because what it is that you, as an ISP, is supposed to declare what your intentions are with your prefixes. Like, these are the prefixes I own, or that my customers own. So you can declare routes, or you can declare which type of customers you have. And a lot of this is stale data. A lot of these sources are not maintained properly. As it is now, RIPE is probably the ones that has the best data quality, which is good for us since we live in a RIPE region. But for other type of IR sources, this has been a big problem. So one solution is to have, which we'll talk about more later, is to have RPKI data essentially drone out old stale entries. Because in a few of these databases, it is really hard to make changes, because they might not be active maintainer. So what most people are doing right now is to have a shim layer on top of these sources. So I think we typically say there is about 18 IRR sources, but no one wants to speak with all 18. So typically you speak through one of the aggregators, which is essentially 2. And it is rr.entity.net and whois.radb.net. Those are typically the 2 default alternatives which you actually ask for IRR data. For example, the only IRD daemon that I know of which is decently good is IRD4, and that is using either entity or RADB. Okay, but we're not there yet. So the entity RR does some of this drown out with RPKI data, but we're not really there yet. So we still have kind of best effort data into these IR sources. So we need to make the best out of it. Okay. And it's essentially what it is you make a query and you try to figure out which prefixes are this operator allowed to announce, and then you put them into your sessions, like this operator is allowed to announce this and this, but not this. Okay. And also, as many people might have experienced, especially big operators, is that excessive filtering will most likely affect your routers in a negative manner. And there's 2 things to this. So big configurations is typically bad for router, especially Junos, which is a monolith, which can take forever and ever to do commits. If you have big configurations, we have configurations which are easily 500,000 lines, and that router gets locked out for 6 minutes before it comes available again to actually do configures in. This might not be a big problem all the time. But I think most vendors have seen this, and most vendors is actually working with this as well. Juniper is also working with this quite heavily into handling this in a different way. Arista, the same thing. I think Peter had a talk here before on how you could do smarter big regexp operations, and smarter ACE path lists, and smarter IP lists. They essentially put them outside of the router instead of in the router to turn the whole thing up. Also, heavy regex operation is heavy, as it turns out. This is a PR which we created, or rather that we kind of found out that we had ACE path groups which was above 10,000 lines, and that made our RPD just crash, and then the router crash. And if you're frequent on Honest Networker, you know there's a couple of memes out there on that topic. Yeah, here's an example. This is our peering router in Amsterdam. It has 33,000 lines. Takes about 2 to 6 minutes to commit in that. And that is because it needs to essentially do a GCC compile on the whole configuration, which is causing problems. And which is kind of weird because this is just control plane anyway, so it doesn't need to, for example, control a data plane or program a data plane to be able to achieve this. This is just control plane. So it's a bit just an unfortunate design. Okay. So what we actually need from this R data, the thing I think you must have is to filter your customers. And I think, of course, you should filter your customers with RPKI data, but that is not going to happen anytime soon in a big sense. So we probably need IR data in between. So this is, for example, a tool to generate IR data. It's called BGPQ3. It is, in my opinion, the only tool available right now which are decent to do this. For example, what we do we use Cisco NSO4 or NCS as administration, so it's just calling on BGPQ3 in the back from a service to generate these filters automatically every 4th hour for every customer. So what it does, in this case, is Bredbandskollen, which I use an example because they had a very short record, which was handy in PowerPoint. So what it does is ASBBK is their AS set, so that's IRR data. That is something they have created, which they they then have formed 2 prefixes in. So they have put 2 routes in their AS set, which are these 2. And here you can see how it will look like, for example, in a Juniper, and how it will look like in a Cisco, depending on which flags you give to BGPQ3, what type of configuration you want. So it actually, BGPQ3 already creates the configuration. It's the same, it can do Nokia, Arista, and even Bird configuration, I believe, automatically, just from the command line. So it's quite nifty. This will, and what will happen here is that you will inherit this into a BGP policy of some sort. Same thing if you, for example, this is, I would say that this you must have on your customers, that you do a per prefix filtering. If you do peering, it might be harder. A few peers can be really, really big. Hurricane Electric has peers with everyone, and they have 180,000 prefixes easily. So those will, of course, put a lot of strain on your routers, so I would not recommend perhaps doing prefix filtering towards big peers. So then AS path filters might be a better choice. So this is, for example, ComHem, which is typically an eyeball network. They do have some downstream ASNs, but not that many. So in this case, we're instead using the AS set, and we want to make sure that we only allow the AS paths that sits behind ComHem on a ComHem peering. So this is the configuration you would need in a Cisco and a Juniper, respectively. And as you can see, these are typically regex operations. And I think, yes, and why this can become a problem is, for example, this is Hurricane Electric. So if you do aggregated prefix lists, you get 161,000 lines of configuration. If you don't aggregate, you get almost 1 million lines. So I can assure you that no router wants that prefix list without causing any type of hiccup. So that's why the AS path filters is better. They're not, of course, as accurate. They will not, for example, if you do misorigination, so you're using an ASN which are valid, you will not catch if they're trying to leak certain prefixes. So it is certainly not perfect, but it is the best thing we have in this aspect for now. And yes, this is typically me doing a commit on Junos 15.1. Okay. If this seems complicated, which I give you to, it might do, and maybe not everyone has, an automation tool in the back, cannot afford to buy NCS, maybe don't know how Python works, maybe don't even know how to configure your router in any other way than a CLI, then of course this method with, automatically updating configuration a couple of times every day might be hard. And this is actually why IXPs comes to place, because IXPs has been bashed quite a lot lately by me, by others, that they need to also be part, or they're also part of both the solution and the problem here through the route servers. So the route servers are very, very handy tools when you connect to an IXP to get the immediate payoff for the port. Because most networks, maybe not the biggest ones, typically pair with the route servers. Eyeball networks typically pair with the route server. Or sorry, content networks typically pair with the route server. So if you set up a session to them, it's quite likely you will get value pretty fast. And here, since we are on the Netnod days here, Netnod has done a very good job. I think there might be a presentation later on recent improvements in this case. But I do know that there is, most IXPs today does actually do IRR data on the route servers, or IRR filtering on the route servers, maybe even RPKI filtering, which I know Netnod is doing. M6 and DKIX are already doing it. So then you get all this automation for free, essentially, which is quite handy. And which is especially handy if you want to pair with weird networks. Okay, cool. Step 6, now it's time to brag a little bit. I don't want to brag about myself, but you should brag about yourself that you have fixed this. So one thing to do it is, for example, to join the Manners program. So Manners is an initiative from ISOC, which stands for Mutually Agreed Norms for Routing Security. It's like a manifest of things you as an ISP should do to look like you are the part, right? This is Svan and Märkning for ISPs, essentially. So one of the things, which is 4 pillars to Manners. So it's to prevent the propagation of incorrect routing information. If you do IR filtering, you're doing a decently good job of not propagating incorrect routing information. You should also do prevent traffic with spoof source addresses, which is BCP 214, which is another talk we can have. And number 3 is to facilitate that you can be contacted in case of a problem, which means that you have a working abuse, that you have a working knock, that you have, some way that people actually know how to get in touch with you, maybe a phone number to the knock, essentially. I think most ISPs can validate towards this easily. And also the number 4th is facilitate validation of routing information on a global scale. And this is, of course, having your IR data updated, but it's also another thing. Okay. And if I'm also, it should be noted that I am one of the, what's called like promoter of manners here in Scandinavia. So I also have stickers from manners. But I think it's a good thing. There is a few Swedish ISPs which has joined. Nordnet Sunet, Telia has joined, and a few others. So I think this could be a very cheap and easy way to show the world that you're actually doing a decent job. Okay, step 7. And that is to do step 4 of the manners concept, which is to facilitate validation. And if you're an ISP and you don't know what you need to do, this is the 4 things you should care about in terms of how to make sure that people can do a good job with your prefixes. And that is to make sure that you know what your autonomous number is, or at least know how to update it, and that it is updated. The route and the route sets and the AS sets, and also the RPKI ROAS. And actually caring about these ROAS is important. And I think I will come to that later, why it's getting more and more important. Maybe more important now than for 2 years ago. And ROA is essentially a cryptographic signature of your prefixes. Okay, step 8. You should, of course, this also goes a little bit in the bragging section, that you should support modern paradigms, such as graceful shutdown, for example, to be able to cause as little downtime for your customers as possible. This was a talk I had last year about graceful shutdown. I will not mention it more than that, but I think it's something you should do. It is super duper easy to implement, and it shouldn't take people more than 5 minutes to get this into the network. Like, really, you shouldn't. Even if you run your network with expect scripts, this shouldn't be hard. Okay, 9 minutes ago. Exactly. Modernize your BGP border, acquire currency. As the famous meme would say. Okay, now comes the last thing. This was actually, my last version of the talk actually started with this slide, right? And then it was 40 slides after that. Now it's like 3 slides. So this will be the short info on RPKI and what's actually happening. So, any network, first this is like a 2-tiered approach, by the way, because when you say RPKI, you typically mean 2 different things, depending on who you talk to. So if you believe that you have a network, or if you believe that you have something which is important, if you have an important website, a DNS system, or a web shop, or a game, whatever, if you believe it is an important IP address of some reason, then you should probably make sure that either you or the one that operates your lead actually registers a ROA. Since we typically are RIPE people here, it is super duper easy. This is output from the Sunet lead portal. And we have a couple of prefixes here, which is currently seen on the internet, which all has ROAs registered. But if you want to register a ROA, it will appear here, a prefix, and it will say that you probably don't have one. And then you click in that box, and then you click the wizard, little wizard rod, and then it makes everything for you, and then you were done. So this is also a 5-minute job. The only thing you should be, of course, aware of is that the data is correct, that this is the actual prefix size you wanted to use. If it's a /24, or maybe if it's /22, but you still would like the availability to announce them as /24s, then you can register a to and from netmask. That is essentially the only choice you have. In other regions, it's much more cumbersome. For example, the ARIN thing, still require a fax, which is, you get almost baffled when you hear it. So this is one part of doing RPKI, that is to register your prefixes. And this is especially for stub networks, then your job kind of ends here. Okay, then we come to the network part of it. This is what ISPs should do, or rather networks that have some kind of transitive function on the internet. And that is to start filtering on RPKI routes. And this is kind of this is a picture I stole from Cloudflare. It's 3 steps. So first, you need to validate ROAs from the rears. The rears is a couple of these, or it's actually these ones. So these, if we translate this into SSL and TLS terms, these are the CAs. There might be more going forward, because not everyone is happy how the rears are handling this. We'll see if we need like alternatives rears or alternative CAs for this. But for now, this is what we're using. All of these are typically automatically integrated into these tools, except the RIN, which you need to, because there's terms of service which you actually need to accept specifically. So all these rears are integrated except RIN, which you need to click on a button, and then it gets automatically accepted into the validator. So what's happened here is that you have a validator which does the validation of the prefixes from all the rears. It will transport these validated certificates to your router with RTR, and then the router will be able to build a database on which prefixes are validated, or rather in which state they are validated. Okay, and first you need a validator, of course. So right now I would say there is 3 alternatives. There might be 4. Cloudflare is doing, I'm not sure they're doing something, but it's it's not a complete validator. They have like an RTR thing. But this is the old one, the RIPE NCC. I mostly had problems with it. I think that Carl Fredrik in the back here also says, yes, I also have problems. And I think most others on the internet also had big problems with the RIPE validator. It is quite old, it's written in Java. I had crashes all the time and was eating memory and didn't work. Then the fine people at Netnod Labs, which are actually the ones that actually created the RIPE NCC validator from the beginning, made a new one in Rust, I believe. It is a Docker container, so it just works, I guess. It was up running in 5 minutes, and I haven't had a single crash with it since then. There's also an OpenBSD version which is coming, and the fine people here at Netnod, I sponsored from Sunet, IIS also sponsored it to get another client out based on OpenBSD. That is coming out very, very soon with a working client, so hopefully that will also be a viable option. But for now, if anyone wants to do this, I would definitely recommend Routinator from Netnod Labs. And configuring this is super easy because RPKI was actually invented quite a long time ago. So most of the vendors already has been pushed and been bullied into implementing this like 10, 12 years ago. So it's already been there. So this is configuration from a Juniper, and it's 6 lines of configuration, then it's done. And if you want to try it out, this is the Nordernet RPKI validator, and it's open for everyone. So if you want to try it, please do. It will probably cope with it. Otherwise, I just lock it down, I guess. But so far, I know that a few other networks is using it, and it's working fine. If you want to try it out, please do. It's OK. All right. And then the last step is to implement this into a filter. You need to do something about it. And this is also, I've come to learn that people are a bit unsure what to actually do with this data. So the thing why it has been popularized these days is that we only care about one thing, and that is the invalid ones. As you can see here, I have 3 terms. This is also from a Juniper BGP policy. And the only thing, as you can see, where we do something is on invalid state. So if something is invalid, which means, and if something is supposed to be invalid, which means that there is breaking a valid announcement. And that is the thing we want to solve. For things that are unknown, because as it is today, like 90% of the internet is unknown because they didn't register a ROA. So the only thing we want to make sure is that if someone is doing a valid announcement, for example, Google is doing a valid announcement for their 8888 resolver, we want to make sure that no one can hijack that. So that's why we only care about invalid. So if Telecom Russia tries to announce this, it will be an invalid announcement. And then we will not program it, they will not accept it. However they try to manipulate to get the traffic, we will not accept it. And this would, for example, I guess everyone had read a lot of blog posts regarding the Amazon Route 53 hijack. They could have actually been helped out by this, since they didn't register a ROA for their prefix, but a lot of ISPs were already doing ingress validation and could have blocked that prefix from propagating. So this is what we mean today when we say use RPKI. that you only care about invalids, block the valids, don't care about valids, don't care about unknowns. Because, you know, in the original specification or in the original thought is that we only care about valids, that we block invalids and that we block unknown, but that will never happen, right? This will happen at the same day that we turn off IPv4. So I mean, it will never fly. But caring about invalids is actually a viable strategy. So is this just a fad? Can I just ignore it like we did last time? I mean, this was hot shit 10 years ago. And then everyone just ignored it, and then it went away. But can we do it now? Well, I don't think so. For example, Cloudflare, they are deep into this. They have built a massive infrastructure to support like information about RPKI, and they will do strict validation on all of their POPs pretty soon. This is an old blog post, right? So yeah, 20 December 2018. So they've already up to 75% at that time. Also, this email was one of the best emails I got in a long time, which was sent out to the Netnod mailing list, was that the whole AT&T network is doing this. And what is good when this happened is AT&T is so big that all of these operators which were lazy and have a lot of invalids, they just couldn't reach AT&T at all. It was like, yeah, we can't reach AT&T. And AT&T is so big, so they can just like, that sounds like a you problem and not an us problem. Which is great, because then after this email went out, like 10% of the invalids on the internet were fixed immediately, because everyone needs to reach AT&T in some way. So it was great, and we will have more big ISPs do this quite soon. Oh yes, there's more, of course. So route servers also do this. M6YOX, DKIX does this today. Netnod is kind of done. I'm trying to find Emil to see if we can see how many days is left before we do this on the Netnod route servers. All the IXP manager-based IXPs is also soon very there, so that we can get this on IXP manager-based IXPs as well. And then we're starting to get almost, you know, a critical point when this will actually work. There is a few other big ISPs. I know Telia Carrier is, for example, soon there. KPN is already there. And if, GTT is also soon there to block this. And when these big operators does this, that's when you actually get value for the money here. And so people should start caring about this. And the next question is, of course, which is, if this talk was another half an hour, we could do this. But since I already assume I'm out of time, which I am, which is good timing, I guess, is this worth without path validation? For the people that care about RPKI, you know that there's not a path validation aspect to it. And the short answer is yes. And why is, yeah, we'll talk about that in a bar. A few good sources if you want to read up on this. As I said, I hope that this presentation gets online afterwards so you can just copy-paste things. I think these are the best sites to visit if you're still unsure what I'm talking about. I think actually the FAQ from Net Labs is one of the best ones available, which answers hopefully all of your questions. And I'm done, and I'm 3 minutes out of time.
Okay, Hugge, that's perfectly timed. I'm afraid we don't really have any time for questions, but you'll be at the social tonight?
Yes.
Okay, thanks Hugge for a great presentation. Thank you. So the second speaker of the session is Erik Hjelmvik. He's the CTO of Netresec. He works with incident response and network forensics. He started analyzing network traffic from a security perspective while working at the R&D department at a major energy company, where he focused on SCADA and industrial control system security. And he's also worked as an incident responder for more than 5 years at the Swedish Armed Forces CERT, where he worked with network forensics and network security monitoring. So please welcome Erik to the stage.
Thank you, Rob. So I'm going to talk about something called man-on-the-side attacks. Who knows what a man-on-the-side attack is? Anyone? Okay, so who knows what a man-in-the-middle attack is? Okay, good, lots of hands. So let's start there. This is a way to visualize what a man-in-the-middle attack is. So we have Alice, who's trying to talk to Bob, but somehow Mallory gets in the middle. So Mallory can intercept all the messages between Alice and Bob. Mallory can replace messages between Alice and Bob. He can inject new messages or just remove the data being transferred. So this way, Mallory can read out passwords or secret messages or change secret messages into something else. While a man-on-the-side attack is more like this. Here, Mallory is not really in the middle. He's on the side. So he can still intercept messages between Alice and Bob. He can also inject additional messages into this communication. So you can send a new message, but he cannot remove any signals, he cannot remove messages, and he cannot modify any messages. So that's the important limitation when doing man-on-the-side. The term man-on-the-side attacks became widely known after Snowden leaked a lot of slides about NSA's quantum insert project. And this is one of the slides he leaked, and that was published in Der Spiegel. So what's happening here is that, let's see if I get a pointer, we have a user somewhere in the Middle East who's trying to visit a website somewhere in Europe. This user in the Middle East visits this website through a satellite link. The GCHQs here, they have a satellite dish, so they can receive the signal, because satellite traffic is broadcast. So basically, you just have to have a satellite dish in the right region, and you can read this transmission. And for some reason, they decided, yeah, they send the signal to NSA, and they say, this is our target. This is the person we want to infect. What the NSA does then, they inject a malicious response back to the user in the Middle East. And you can see they inject the response somewhere close. They don't inject the response through the satellite link. And that's the second reason why the NSA loves satellites, because one, it's broadcast, but two, it's very high latency. Especially geostationary satellites, they're very high latency, because the NSA have to send their response to the client before the actual response come up and down through the satellite link. So since it's a slow link, they have a good chance of actually beating the proper server response with their injected response. And that's how they, well, that's on a top level, that's how they try to infect the user. So a different question. Who knows about the company, the hacking team? I see a few hands. Okay, next question. Who more than I thinks that this guy looks a lot like Zlatan Ibrahimovic? Right? Well, actually, this is Zlatan Ibrahimovic. This is Zlatan. This is the hacking team guy. This is Zlatan. So totally different persons. But anyway, sorry about that. But the hacking team, what they do is they sell servers or technology to infect people's computers or people's phones so that they can extract information from them. For example, data that would otherwise be encrypted. But what's interesting with the hacking team is that they themselves got hacked in 2005 by a guy who calls himself Phineas Fisher. And one of the things that Phineas Fisher did was that he released email communication, internal communication within the hacking team. And there's one very interesting email thread where they're talking about the NSA quantum insert program. So this guy, Marco Catino, says that, hey, there's a cool link here about the NSA doing quantum insert. And he says that it's very similar to NIA's features. So apparently they have something called NIA or NIA that's similar to quantum insert. And then this guy, Alberto Naghi, who's one of the brains in the hacking team, responded and said, yeah, there's still other technology and ideas, but what can we do? Sue them, ha ha ha. This is proof that our idea was good. And then finally, this guy, Serge Boone, chimes in and say, yeah, we can sue them for infringing patent, smiley. So I was like, what? They have a patent for man-on-the-side attacks? That's cool. So I Googled a bit and found this. So they actually have a patent for man-on-the-side attacks. So for some reason, the hacking team developed this technology alongside NSA, because this was sort of in the same time frame. And if you scroll further down in the patent, there's a very good slide that shows how the man-on-the-side attack works much better than any of the stuff that Snowden revealed. So I'm going to step through this carefully. So you can see it starts with a GET request. So we have on the left, we have the target. That's the person the hacking team are trying to infect with malware. This person is trying to visit a server, but somehow the hacking team have their man-on-the-side product in the middle here. So first thing that happens is that the client sends a GET request to say, I want to download this exe file from this web server. They sniff this packet and say, okay, now he's doing a GET request for an exe file. That's interesting, let's use this. And since they're only sniffing traffic passively, they cannot block it or do a man in the middle of it. Instead, this packet will make it all the way through and to the proper server. But they can inject an additional response. So they spoof a response packet, and they have to make sure that their spoofed packet arrives at the client before the proper response. So they spoof a response, and you can see the response they're spoofing is that they're sending a 302 found, which means that, oh, you're looking for this exe file. Well, we moved it. It's somewhere else right now. And somewhere else in this case is a fake subdomain. So the user is trying to download the file from example.com, but they're saying, oh, go look at xyz at www.example.com. And this subdomain xyz is a subdomain that doesn't exist. They just make up a completely new subdomain in this location header. Then, of course, the proper server will send the 200 OK and the exe file, but the client will actually ignore this 200 OK from the server because it has already received the proper response from the injected packet. So it will not care a bit about the response from the server. So instead, the client will continue and say, hey, I need to go to xyz.www.example.com to get this exe file that I really want. But he doesn't know the IP address of that server, so he's going to do a DNS lookup. Again, the hacking team are sniffing the DNS requests, so they can see, oh, now he's doing a lookup for this fake subdomain we sent to him. And this DNS lookup will go make it all the way to the DNS server. But again, the hacking team can spoof a packet, so they can inject an additional response. So they inject their own response, and again, they have to send the response to the client before the proper response. But this time, they give the client an IP address that the hacking team themselves control. So they give them an IP address to a server that they run. And shortly after, the proper response will come and say that there will be an NX domain response saying, basically, there is no such domain with that subdomain name. But the client won't care about the NX domain because the client has already received a proper DNS record with pointing to a hacking team server. So the next thing is that the client connects to hacking team's actual server now, saying, hey, hacking team, or he doesn't know it's hacking team, he believes it's just subdomain of example.com, saying, now I want to download this exe file. Hacking team server say, hey, great, he's trying to download this exe file. Then they go ahead, connect to the real server where this exe file is actually located. They download it from the real server, and they modify the file. So they embed some piece of malware or some type of exploit into this exe file and send it back to the client. So the client will, if you look at this from the client's perspective, the client clicks on a link on this proper valid domain for this exe file where you're supposed to download this binary. He gets an exe file, he runs it. He doesn't really notice all these directs and faked responses. But from a defender perspective, what you want to do is, how would I detect this? How would I detect this type of attack? And there are two places I'd like to look. First place is that in this GET request, there's actually two responses coming in. The TCP/IP stack will actually ignore the second response, but only care about the first one. But if we look at it at a packet level, we will see that there will be two packets in the same TCP session with the same TCP sequence numbers, but they will have different data in them. So that's something we can look for. Second thing we can look for is on DNS traffic, because we will send one DNS request, but we will get two DNS responses for that one. And those responses will have different contents. So one will, in this case, one of them points to an IP address, the other one says the domain doesn't exist. So if we start with the DNS, it will look something like this. So I created a definition of, okay, what do I consider a DNS injection? So I say that it has to be two DNS replies where both DNS replies have the same source and IP, and source and destination IP. They have to have the same source and destination port, and they have to have the same DNS transaction ID, or I just call it DNS ID. But the DNS records in the response need to be different. I also said that I need to see two such responses within the same hour. The reason I did that is because I wanted to try this on my own network traffic, and I have like lots of historical network traffic from everything I do, and it's segmented by hour. So I just want to look in one PCAP file and see, do I see two responses in this PCAP file with the same source and destination IP, source and destination port, same DNS ID, but different resource records within the same PCAP file. So I did this, ran through all my PCAP files, and I got lots of alerts, lots of them. So here's like one of the hours where I had most of the alerts, or I had lots of alerts during this hour. You can see here that this looks like there's Ubuntu machine. You can see here's the queries the clients are sending. So it seems to be a Ubuntu machine running Firefox that's booting up here. So it's the Firefox browser is starting on the Ubuntu machine. So it's doing all sorts of lookups. But can you see what the problem, or something that's strange about all these lookups? What do all of these have in common? Can anyone spot it? Yeah? The same address of the, you mean of the client and server? Yeah, and it's the same, like if you look on the port even. So it's the same client talking to the same DNS server all the time. And DNS server is, of course, talking on port 53. And the client is, for some reason, the client decides to send all its queries from port 62,050. So, of course, you can do this in DNS. You can just pick one port and just stay with that port and send all your queries from that port. But it's not good for several reasons. One of the reasons is an attacker could easily, if they know you're always using port 62,050, they can just inject fake responses to port 62,050, and hopefully, one of those responses will be accepted by a client, so they don't even have to sniff your traffic to inject fake responses. So therefore, the client port is typically randomized. For every new DNS query, you pick a new random high port and do a new query. But in this case, this Ubuntu machine decided that, no, I don't need to randomize the port. I'll just use the same one all over again. But luckily, at least we've got some entropy because the client, we have something called a transaction ID or the DNS ID. So that should be unique for each query. In the old days, you would usually increment this by 1. For each new DNS query, you just incremented the transaction ID by 1. So if we would do that, then that would mean that I would need to have more than 64,000 queries before we would start repeating, and we would get an overlap with the same query ID again. But for the same reason, we're randomizing this, because if we would do this incremental, it would be very easy for an attacker to know which would be the next query ID you're going to use and just inject a fake response to you, and that will be accepted. So therefore, we randomize this DNS ID all the time. But the problem is when you randomize the DNS ID, you will get collisions much faster. So the birthday paradox tells us that we actually only need 300 unique DNS requests if we're not randomizing the port. We will, after 300 DNS IDs, we have a 50% probability of getting a collision in the DNS ID value. And in this case, if we go back, the client did more than 1,000 DNS requests. So of course, there were a lot of collisions here. So I got a lot of collisions. So I realized that, OK, my first script to find DNS attacks or DNS injection attacks, it wasn't good enough. So I had to be more strict. So what I did, that I still said that we need to have the same source IP and same destination IP for 2 DNS responses. They have to have the same DNS ID, different records. But instead of saying they should proceed within 1 hour, I'm saying that the 2 responses need to be 2 consecutive responses without any other response in the middle. So we see 2 responses with everything the same except for the DNS records. Then it's a DNS injection attack. So I ran this again on all my PCAP files. Oops, sorry. And this is what the script looks like. Actually, to say it's a script, it's actually just a bash one-liner. So, but what it does, it's TCP dump, reads a PCAP file, filters on port 53, looks for packet that have a DNS ID field, and the purple parts here, that's the stuff that I want to be the same. So I wanted to see 2 responses where the purple part is the same, and I want the red parts, that either DNS CNAME or DNS A record, to be different in 2 consecutive responses. And if I see that, that's when I alert. So I ran the script, and hopefully I shouldn't get any alert on my traffic, but I actually got alerts. So I was like, what the heck? And what I realized that, okay, I have a different problem now. Because for some reason, I have some DNS clients seem to retransmit the same requests more than once. So they send the request, and then they send the exact same request again, using the same source port even, and even the same DNS query ID, or DNS transaction ID. So I see 2 identical requests being sent, and normally if you would query for that, like go to my website, like netresac.com, you will get a response saying that, yeah, that's over at 195.something something. And in the second request, you will get a response saying, yeah, it's still over at 195 something something. My script would handle this because, yeah, then the DNS records are the same, so it will not alert on that. But of course, there are many sites where the responses for each request will be different because they're doing load balancing, or maybe there's a content delivery network where they spread out the load throughout a lot of IPs. So in this case, here's one example where this happened. So the blue part, that's the first request, and the white part are the second requests, or the responses from the second request. So here's actually, there's a service called the Crashlytics. So I think there's an app here that crashed for some reason, and it sent some crash information to crashlytics.com. So when it crashed, it does a lookup for each Crashlytics, and it actually does this. It sends 2 identical DNS lookups for crashlytics.com and gets responses. And they look pretty much the same in response, but you can see that the IP addresses are different. They are somewhat different, so they're not the same. So that's why my script will alert on this. But I could see that, okay, but it doesn't seem to be a malicious response, any of these, because they're all hosted on Amazon, just different IPs on Amazon. Although I'm not 100% sure it's not malicious, but that's my best guess. So I'm like, at this point I felt like this. I'm sitting here trying to find DNS injection attacks, but I'm failing because all of the messiness in how DNS normally behaves. So the normal behavior of DNS is a bit of a mess, so therefore it's very difficult to find the attacks. But at least what you can do is you can, of course, protect yourself against this type of attacks. So one way is, of course, to use DNSSEC. But if you use DNSSEC and want to be protected against these attacks, you have to be prepared to ignore any responses you get that are not signed, or ignore the responses you get that you cannot validate. So you have to really enforce this. Another option, which is becoming quite popular, is to use DNS over HTTPS or DNS over TLS. Then you have a different issue. It's more like, who do you trust? Who do you send your DNS queries to? And there will probably be higher latency also. So it's performance issues as well. And the fourth solution here is run your own DNS server. Don't use anyone else's. Your own DNS resolver, exactly. But then again, somehow, that resolver doesn't know about everything, so it will have to query stuff. So you have to, it might not be protection, but at least you limit your exposure. Or you can go extreme and take the advice from DNS Borat and just put everything in ITSI hosts, right? It's good for privacy, and you'll be secure because you don't need to use DNS at all. It's very impractical though, so secure but not practical. So, but we had a different place where there were problems. So now we've talked about DNS, but the bigger problem is actually here up on TCP or HTTP, because this attack could have been pulled off without DNS at all. They could have sent just, 302 found, go to hackingteam.com and download this exe file. And the browser would actually go to hackingteam.com and download this exe file. So they actually don't need the DNS. So this is the more important part. And for this 302 found response, what we can do is we look for 2 TCP packets in the same TCP session with the same TCP sequence numbers, but different data. And I've written a script to do this, and it works very reliably. So it's called findject.py. It's available on my website. So it's just a Python script. Please feel free to use it. It's very simple. You just run it with Python and give it a bunch of pkip files in the argument. It will then run through the PCAP files, and will say for each PCAP file, it will say if there's an injection or if there's no injection. If there's no injection, nothing fancy. If there is an injection, it will print a 5-tuple, so the source IP, source port, destination IP, destination port, and it will print a sequence number where there were 2 duplicate packets, and then it will print the contents of the first TCP packet and the contents of the second TCP packet. So you can see that, hey, they're different, right? Then you got a man-on-the-side attack. So I ran this script on my PCAP files again. So, okay, hopefully I shouldn't find anything, because this is very reliable. But I actually found something. One of the computers was doing a Windows update. So we contacted the server of Microsoft saying, hey, I'd like to download this Windows update. And for some reason, I got when the bits client, which is used for doing the Windows update, it actually just doesn't download the whole cab file as one big chunk. It downloads piece by piece using something called partial content, doing a range request and gets a partial content response. And when doing this, a few segments in this Windows update were actually different. So I looked at it, and I looked at the data, and saw that, well, the file data I'm getting is actually identical in both packets. The only thing that differs is this header, this XHW header. And X headers is something any server can just append, but in this case, I'm guessing it has to do with something about hardware. So I'm guessing Microsoft is running a load balancer, and the parts in purple, that's the parts that differs. So I'm guessing that Microsoft is running a load balancer. My client contacts the load balancer. The load balancer contacts its internal servers and say, hey, servers, who's going to send this piece of Windows update to Erik? And 2 of those respond that, yeah, I've got this. And for some reason, the load balancer let both of those replies back to me. And this was happening. I saw a lot of this behavior during this day, December the 12th, last year. And these packets will, of course, have the same sequence numbers. They will have the same file contents, but it's just this XHW header that's different. So, of course, my script worked because it was supposed to detect stuff like this, but it wasn't an attack. A question? Yeah.
What is GMT?
Timestamp? Oh, sorry. Yeah, you should tell them. You mean to have a more precise UTC time zone? Well, out of scope, sorry about this, but I'll be happy to talk about this in the break. So I got a different response. Now this is a different, so I dug deeper into my PCAP files, went way back, and I actually got something very interesting in 2016. So I was like, yeah, or what the heck? I don't know how to react to this, but I'm doing a GET request for this 02995.com. I'm getting 2 responses. And this looks nasty, right? This looks like the examples from the hacking team. I'm getting 2 responses. The first response is at 302 found, which basically says, hey, this file is somewhere else right now. Go to this website, how123.com, to download it. It's like, okay. And then I got a second response saying, no, this file is not there anymore. It's on how360.cn. So I got 2 type of redirects. So I don't know really which one is the malicious one, which one is the regular, is the proper one. I don't know. So let's just look what these websites look like. What if I can actually connect to that URL? So the first one, it's actually a Chinese start page. Looks like this, like basically start landing or start page from a telco provider or something. Okay, seems legit. And then the second one, well, it's a different start page from a competitor of them. So it's like, now I remember. So this is an actual man-on-the-side attack that I triggered on purpose in 2006. So what I did is I contacted this server in China, this 02995, requested this, any file on their server, and what they're doing is that server in China will respond with this move to say, oh, we moved it, it's now on how360.cn, go there. But for some reason, I got this 302 found as well, and that's actually injected by a Great Firewall of China. So on the perimeter of China, someone's injecting a fake response because they don't want me to go to this how360.cn. They want me to go to how123.com, which is, as I understand it, it's a competitor. So they want to move people who are outside China from this company to the other company for some reason. I have no idea why. So, and the reason I was looking at this, because I was validating a research that was done by these guys. So there's a very good research paper called Website Targeted False Content Injections by Network Operators, where they looked at 180 terabytes of data of HTTP traffic from 3 universities and 1 corporation. And they found a lot of suspicious traffic that seems to be man-on-the-side attacks. So to protect against TCP injections, my recommendation is always use HTTPS. So either you explicitly type HTTPS:// and domain name, or you use a browser extension that does that for you, like HTTPS everywhere. Because if you don't type HTTPS, just type www.google.com, you will connect to Google on port 80, and Google will do a redirect for you to port 443. But if someone is doing man-on-site on you, they can see that request on port 80, inject the redirect to server they control, to hackingteam.com. And you will go to hacking team, they will affect you, and then redirect you back to Google, and you might not even notice. But of course, there's a lot of traffic. Even though you do this for a browser, there's a lot of other stuff on your computers, device, phones that talk HTTP unencrypted anyway. So if you really want to block it, you really need to block port 80 traffic in a firewall, which you might not want to do because stuff will break. So that's a problem. It's difficult to really stop all of port 80. And another problem with this is actually sort of a vulnerability in the TCP/IP stack. And there's no way we're going to patch this. This is going to be around anyway. So the best thing we can do is use some type of protocol that enables us to authenticate each message from the other end to make sure that we can actually throw away messages because they're not properly signed. So yeah, that's it for me. Thank you. Any questions?
So we're a little bit tight for time. I suggest if there are any questions, you could take it in the coffee break, if that'd be okay.
Perfect.
Great. Could you join me in thanking Erik for a great presentation? Thank you so much. So the final speaker of this session before the coffee break is Jasper den Hertog, software engineer in the R&D department at the RIPE NCC. He works in cleaning, aggregating, and visualizing networking-related datasets and turning them into APIs. He is a core developer of RIPE Atlas and RIPE IPMap and works in the, as I said, RIPE NCC R&D department. Please could you welcome Jasper to the stage.
Hi. Yeah, so I'm a software engineer in the R&D department of the RIPE NCC. I'm not going to tell you what the RIPE NCC is, because I think you all know. But in the R&D department, we make a few services, although we call it research and development. The most famous of which is probably Atlas. And I want to briefly go over some new stuff that we did recently. That's not somewhat related to the Atlas, but different. So we also make RIPEStat, which hosts like basically all of the data sets we collect on our own, and third-party data sets that we think are useful, and data sets that cross the RR boundaries. So this is a point of confusion that I hear every once in a while, that like for lots of data, like IRR data, we host data we can get our hands on, not only our own RIR collectors, but also from the other RIRs, and I think even RADB. One notable small feature, but significant, is that now you can see in the AS routing consistency widget, you can see RPKI ROAS. So this is our AS, which seems to be sort of fine. Again, you probably would be interested in valids and invalids. So unknowns are at this point not so interesting. One note though, at this point in time, RPKI will of course do only origin validation and something around path length, maximum path length. But probably, hopefully in the future, this is sort of step up if the ESPA proposal is going somewhere, which is basically validating BGP adjacencies, and then it gets interesting because then we can validate parts of the path. So this is our Yeah, and then another thing is we, for ages, we've had the risk collectors. We have 21 of them. So we have basically a route service that only collect data from people and organizations who are willing to peer with us at the locations. And we have one where you can remotely peer to. And also for a long time, we had I think, demo.ris.live or something, that would stream all of the announcements and withdrawals that the collectors see in real time. But it was sort of hidden and a sort of demo. But now this is an actual product. There's a complete labs article on labs.ripe.net. But what it amounts to is that we have a backend that gets all the data from the risk collectors and will emit it over WebSockets and over SSE, server-side events. So you could both write scripts for that. There's Python libraries, there's 2 or 3 Python libraries that will actually be able to ingress those, ingress the data, and you can do whatever you want with it. And of course, you can stream it into browsers. WebSockets were made up in the browsers. So, yeah, if you want to have more information around it, please talk to me. I'll be most willing to help you out and to point you to the locations where you use this stuff. Then there's RIPE IPMap. This is like now over a year old. The inception is like 5 years old. I will get back to that. Basically, what it does is, well, it tries to geolocate the core internet infrastructure. It consists of 2 interfaces, basically. One where you can look up IP addresses and you get back a list of locations. And the other one is it will try to visualize trace routes from the RIPE Atlas system. So active measurements that are done from the RIPE Atlas system. You can actually, on the measurements pages of RIPE Atlas, you can, if there are trace routes, you can have visualizations like this. I'll go back to that later on. Another thing is, also for 5 years now, we have been experimenting with the IXP country jedi, which tries to get information from the RIPE Atlas system by making active measurements within a country or within a region, from probe to probe in a matrix, in a full matrix, and see what kind of data we can arrive from that. We've made a new visualization around this, combine it with a new data set from APNIC that tries to estimate how many end users there are in a AS within a country. So that's a per country data set that hosts all the ASs that actually have end users in them. It's a controversial data set, by the way. There's large caveats around the way they collect this data and the way they correct it. But it's the only data set that we know of this type that does this kind of stuff. So if you know of a better data set that we can use, please let me know. I'll go into more detail later on. So the meat of this talk was, we were asked the question in 2015, Emil Aben, our head of research, gave a talk here, which was basically the first country jedi thing that he made. He made a special run of all the probes to all the probes in Sweden, and next to that a run of all the probes in Sweden and Denmark combined to each other, and then see whether we could make out whether the traffic intended from probe to probe would stay within this region or that it would go outside of the region, and some other stuff. So back then our house style looked like this. I still like it, but hey. So back then we had like, well, already more than 8,000 probes. And right now we have more than 10,000 probes online at any given time. So we have way more probes, I don't know, 25,000 or something. But at any given time you will see that there are at least 10,000 online. Of these 10,000, I think it said like we had 100 anchors in 2015. We now have more than 500 anchors. More than 100 of which are virtual anchors, which have been basically spun up in the last 6 weeks, I think. So there's a huge increase, a huge. So also, if you want a virtual anchor, so this is basically an anchor, which is a hardware 19-inch thing that you can now run as a virtual device, basically on any virtualization platform. So if you're interested in that, please let me know. Yeah, so Emil set out the components that he was going to use in IXP Country Jedi. And one thing is, he was going to use traceroutes. Traceroutes were pretty new to Atlas back then. And we still do that. Right now we have much better visualization tools around this. My former colleague, Massimo Candela, made a visualization for traceroutes, a graph visualization, where you can see for a measurement how which routes you see, and where they join up, and how they evolve over time. So this particular one, you can see here, these are the probes on top, and they go to the same destinations, and they all seem to join here, which is probably an NE100 IP address, I guess. And there's these trees here, they end up at this node. And if you would go over time, you would see this change. Back then, Emil basically started with what was then called Open IPMap, which is called now RIPE IPMap, a project to get the IP core internet infrastructure located, basically by means of crowdsourcing. So he basically set up a database that anybody could enter IP address in where they knew the location of. And this has also been involved into a product right now that looks like this. You can, it has a UI where you can look up stuff. So Emil said that he had like 30K infrastructure IPs mapped out in 2015. Right now we have more than almost 200,000. And it evolved in a thing that has like multiple engines stacked on top of each other. The most important of which is not the crowdsourced engine, basically, but the thing that we call the single radius engine. I mean, if you have 10,000 probes online, that means that we have lots of probes in the vicinity of every IP address, basically. So what we do, we schedule, if people ask for a IP address and we don't have it already in the database, we schedule a measurement from the probes towards the destination, and then we kick out all measurements that take longer than, that give us back an RTT of more than 10 milliseconds. And then we look for the best one, and we come up with multiple circles, and we try to, by triangulation, come up with the location. There have been research around this by third parties that found our countries, on a country level, we are 99.9 something correct. And on the city level, we are the best data set around for non-end user IPs. This is still an ongoing work. Most notably, we don't have a very good reverse DNS engine right now. So one of the ways that researchers try to come up with IP addresses is looking at the host names and then figure out from there whether that is whether there's an actual location in there. Like big transit providers are known to have schemes for, with using IADA codes or something like that. Qaeda has done extensive research around this, and they seem to have a really good engine, so we're still working to include that. Then IPMap has an API that you can query. So you can do both. Yeah, this features best in here, but you can leave that out. You will get only one IP address back. Or if it's Anycast, you will get lots of IP addresses back. And you can also specify like partials, and then you will see the specification for each engine. So if you, for some reason, want to rule out one engine, or you want to see like why a particular engine returns a particular result, you can look it up there. Yeah, and then about the interface, so we have already talked about this, right? We have the interface on IPMap derived with net, which is just a sort of convenience thing where you can look up IP addresses. And then there's the thing embedded within Atlas. If you go to a traceroute measurement, you can actually see it on a map. Yeah, and then the one in Atlas will give you much more information. It will basically visualize the complete traceroute with the ASs and all the RTTs lined up. More of that information. And in this interface, you can also add locations, because here it says like add location. So if we don't know the locations and you do, you can actually directly in this interface, that would be here, you can change this stuff. I thought there was a, yeah, so here you could change add location and you would be able to just add a location. And you don't need to be logged in or anything or identify yourself right now. In the future versions, we will probably, if you if you can indicate by logging in basically that this prefix belongs to you. I cannot say that from registration services. When you, I never know what you do with prefixes. You don't own them. You can use them. I don't know. You announce them. You can fill it out, and then it will be a sort of authoritative answer, like the people that have this prefix allocated are saying that it is here. And you can also opt out of geolocation. If for some reason you don't want your prefixes geolocated, you can actually indicate there like, don't do this. Then another thing is, this is not hard science in the sense that we can never be totally sure that something is anywhere. So on the interface, we try to indicate what the sort of confidence around the actual score is. So there's stuff that we're pretty sure that's the actual location. So that would be this full circle. Like, yeah, we figured we have lots of engines that align on this location, and then there's stuff. Yeah, this is sort of a wild guess. And also there would be if people would only crowdsource stuff, it would also stay on the low side of things. That would, because we have no way of validating it, because if we would validate it, then it would immediately pop up here if somebody crowdsources something and we can validate with active measurements that it's actually in the location, it will be this. So this, if there's only crowdsourcing going on, it will always stay in this sort of, yeah, guesstimate. Okay, so yeah, and then in the interface, if you change a location, you will see that the actual trace will immediately adapt to that situation. So that's in 5 years' time where we went from the, with Open IPMap, now RIPE IPMap, from a prototype to the production thing. So then what Emil did was, he actually set out to see if local traffic would stay local, which was somewhat controversial at the time, because for lots of non-Nordic countries, we see actually like places like Belgium or Germany are extremely local. So there's almost no traffic in Germany that will leave Germany if it's destined for Germany. And the same holds true for Belgium. However, for Sweden, back then we saw that we saw these numbers, which, yeah, may or may not make sense. And these would be the kind of paths that we're seeing. There was some traffic going up to M6, some traffic going up to DKIX, and some traffic going up to Copenhagen. So, yeah, these would be, so yeah, he made a, I'll show the first, this would be the full matrix. So this is what it looked like back then. Basically, yellow and green is stuff stays within the country. And blue and red is stuff goes out of the country. We updated this scheme to look like this. We were pointed out that this is far too alarming to have this in red, basically, especially for Sweden. This also, we found out that if you rotate the diagram, it's easier to read the return paths and from the A to B and B to A paths, because basically what this means this are all the probes listed up here and here. So any crossing on this matrix represents one direction, which it should be right because internet is asymmetrical. But on the other hand, there is a relationship between going from A to B and B to A. So here you can sort of, here's a rough indication whether paths are sort of symmetrical in terms of locality of the traffic. So this stuff on a horizontal line is now, that should be somewhat coherent. And this is what it looks like now. Well, that's far better on the, so the brown stuff here It goes out of country, and not through an IXP, if I'm correct. Yeah. So that's almost gone, and the stuff that you see here is pretty interesting. They are anycasted. So that's pretty hard to figure out from a geolocation point of view. If you get like an anycasted, I think this was level 3. Still weird, by the way. Why would you go through level 3 for local traffic from Sweden-based traffic? But hey, but it was an anycast IP address, so that would pop up on multiple locations, and then it becomes very hard to figure out which location that actually would be. We could only, if we did it from the basically context of the trace route, we would say, yeah, it's very unlikely that this thing actually goes to Russia. You know, it doesn't make sense. It probably stays within Stockholm, and the RTTs would also indicate that it's true. However, MPLS tunnels can also throw some sand into that analytical machine. But so this is, if you compare it on the scale, this is 2015, this is 2019. You see that this stuff, so not going through an IXP but out of country, is roughly similar. And the thing is, if you look at the percentages, they're still the same. The only thing that's the real weird stuff going through an IXP and going out of a country, that is just errors, artifacts of our measurements. So yeah, for IPv6, back in 2015, we could not produce the matrices for IPv6. Also, they would be completely uninteresting because they would basically an 8x8 matrix. But now it's much more comprehensive. However, there's much more brown in here. So it's interesting. We have no clue why that happens. I couldn't go I could dig deeper into this analysis why this, but I have no clue right now. So another thing. Oh yeah, that was an interesting thing. In 2015, Emil tried to see if he would kick out Oslo and Copenhagen, what would be left of out-of-country stuff. And you see, like, that's very, very little over here. And right now, you see that's the same stuff. These are artifacts. This is the same stuff, anycasted artifacts. I only think there's like 2 or 3 routes in the totality of what is this, like a 200x200 matrix, that actually go out to AMS6 or something, which is probably an anomaly. The peer-to-peer fabric, very fast, because probably people want coffee now. This is a circle that's a full circle represents all of the ASs and users in a country. The open part of the circle actually indicates not data that we don't know, but ASs that provide less than 1% of the connectivity within that country. So that's also a measure of the sort of diversity of end-user providers, basically. Then within the ring, you see the blue rings are transit providers that function within the country, and the orange ones are IXPs. And then these circles on the edges is the amount of trace routes that go or that start or go through this particular AS, and the size of the segment. This is one AS, and the size of the segment is the percentage of the end users that the AS represents. So, yeah. So here that's rehashed. Yeah, and then there are lines through the diagrams. Also, orange lines indicate these two ASs connect through an IXP, the orange lines, and blue lines indicate that there's apparently a direct peering relation. So this is not BGP data at all. This is only trace route data. So we infer that this is direct stuff. And if it's a dotted line, then we know there's stuff in between, but we sort of figured when it's a direct peering that there's probably not IXPs of transits in between. There's just stuff in between. We don't know what. This could have been sharper. But this is basically what Sweden looks like in March 2019. So we run this stuff every month, like the rest of the IXP country JEDI. And it's a snapshot. So we don't do anything to aggregate the trace routes. It's one run, like one trace route from A to B, B to A. And that's it. So this is Sweden is remarkably stable. But there's countries that vary wildly over from month to month, and that might just be an artifact of the way we do it. But that having said, like this is Sweden is among the most stable. So what you can use, so typical picture for Sweden, I guess. I mean, there's some transit providers in between. So level 3 is the level 3 that with their anycasted net. There's, I don't know what this is, but this is apparently a transit provider. Cogent is in here, but for the rest, it all makes complete sense, right? These are you'll see Netnod Stockholm here 4 times. Those are the different peering lands apparently. So we get the data for all the peering lands from PeeringDB. Yeah. So here you can see probably I guess that this also is somewhat correct. As far as I could see, mainly what I do if I go over to give a talk, I manually see if it makes sense. For some countries, this is really weird. But so the landscape in Sweden is like, so this part would be other ASs, but you can see that these are they cover probably more than 80% of the market. And other notable examples, like very typical things, is like Southern Korea. There is one IXP, by the way, who got a bit upset when they saw this. And we see them once in a while, but sometimes they drop off. This is also because it's a snapshot. Probably if we would properly aggregate, we would see more of them. But this is pretty typical of Southern Korea. So and then there's Ireland, which is sometimes these also disappear. They basically, I think 90% of the traffic goes to INX. Apparently, that's also what they claim. So it's probably good. And then this is United States. Not also because it's very big, but you can see like transit providers play a much bigger role than IXPs do. So like, and then the biggest is Seattle. Yeah, it's 6 Seattle, which is basically probably the largest community IXP in the United States, but still only this little thing. So yeah, this is where you can play around with the country jedis. Especially with the peer-to-peer visualizations, there's a drop-down where you can, an autocomplete where you can look up other countries. Yeah, and I want to conclude with this kind of stuff that every week, I've been not doing this for quite a while, but I'll pick it up again, is looking for weird trace routes in our system. And so this is a trace route that I like very much. It's the trace route that just cannot decide which way to take, like go to the left to the other side of the world or go to the right. So and once in a while it swaps places. So that's it.
So we have time for a quick question or two for Jasper. Otherwise, we can go into the coffee break. Any questions? Okay. Thank you very much, Jasper.
Yep.
So that's the final presentation of this session. We have the coffee break, and please be back here at 3:30 for the final session of today's meeting. Thank you. So welcome back, everybody. It's gone 3:30. Welcome to the final session of today's Netnod meeting. So just a final reminder that straight after this session, the buses will be leaving for the social outside at 5:15, and don't forget to bring your meal ticket. So for this last session, the first speaker will be Åsa Schwarz, Head of Business Development, Knowit Cybersecurity and Law. She was appointed Security Profile of the Year 2017, and she is also a novelist translated into 17 languages. Her last novel was a hacker thriller called The 7 Keys. So please join me in welcoming Åsa to the stage.
Hi, I'm very happy to be here. I'm going to talk about artificial intelligence and security, and is it heaven or hell? How many here think it's heaven? Hell? And somewhere between. Okay, it's a little bit of everything. I haven't already got introduced, so I won't do that anymore. I'm first going to talk about AI. What is it? And the definition, or the definition that doesn't exist. And I'm also going to talk a little bit what is happening right now. And then does AI enhance security and safety? And then the other way around, safety, security in AI. But first, I would like to talk a little about intelligence and what it is. And there are much definitions on intelligence that there are scientists in artificial intelligence. But you could say that intelligence is the ability to achieve complex goals. It could be like we are doing here. We are sitting, reading something. We are going to eat somewhere else, and then we're going home to sleep. There are very few computers today that can do something like that. But then we have narrow intelligence. Then it's about achieving a small set of goals. It can be playing a chess game, or counting, or a simple program. So we have narrow intelligence, and then we have general intelligence. And general intelligence is what we have, what humans have, and that computers don't have today. So artificial intelligence, it's non-biological intelligence. And we have general artificial intelligence that can perform tasks as a human being. And today we don't have any systems that can do that. And then we have super intelligence, and that is what you see on sci-fi movies or read in sci-fi books. I think most of you have heard about Skynet and stuff like that. You can also look at it like this. Today, a lot of companies are working with automation of recurring or repetitive processes. And they say that they work with AI, but it's actually not AI, it's just what we have been doing. It's digitalization of processes. And then we have cognitive tools like chatbots and stuff like that. It's a little bit close to AI. And then we have AI that uses a lot of information and data and calculations. And it's not general intelligence, but you could call it AI. And if we see what is happening right now, and I think this is the year that AI actually is no longer a PowerPoint product. We have seen a lot of discussion about AI since, I think, 10 years back. But today we have a lot of applications that are hitting the market. And I would like to show one of them. This is Furhat, and it's a startup from Stockholm. Do you think we could show the YouTube clip? Oh, okay, you're awake now? Will it work, or shall we skip this part? Okay. Okay. This is advertising movie, and this is the application. It's a robot, one of the first social robots that are manufactured for a large audience, and the reason is that it's much cheaper than the robots before. Okay. Another example of application that it's manufactured today, it's driverless cars, and this is a Volvo. And Volvo has as a goal that in 2025, have 30% of all their cars made without driverless cars that are driverless. Another example is this little robot. It was in Norrköping, a small city in Sweden. They had 5 robots in the schools, and they gave the students, they asked the students what to do with it. So they used the robot for gymnastics, mathematics, and a couple of other things. And what they noticed was, and that I think it's really interesting, that kids with special needs preferred the robots than the teachers. So some kids really can benefit from having robots instead of persons as teachers. Not always, of course. I think most of you have seen this picture. It's Google's new assistant. Have you heard it? Many people have, it was launched, I think, 3 or 4 months ago. And the interesting thing with it is that you can't hear the difference between a human and a robot. And that raises a lot of questions, especially when you work with security, what you can do with something like that. And I will talk a little bit more about that later. So if we look at the timeline of AI, somewhere in the 60s and 70s, they made a lot of research in AI, but nothing happens. I actually thought about studying AI in the 90s, but it was so boring because you couldn't do anything. And what then happened was narrow AI, and we are now somewhere here, where we can do quite a lot of stuff, but we can't do general AI, and nobody knows when we reach this. But there are the only foil hats that worry about AI, and people like me that work with security. Now there are quite a lot of people that do it, and in 2015, there was a lot of researchers that gathered in Puerto Rico to discuss AI and the consequences of AI in society. What they did was an open letter, research priorities for robust and beneficial artificial intelligence. And there were actually some Swedes in these pictures, and one of them was Max Tegmark. Have you read this book? No? No? What? Ah? Did you like it? Yeah? Yeah? And I can, if you want to know more about AI and security and the history of AI, I really recommend that book. I'm sorry, it's in Swedish there, but it's also, the book also exists in English. Another thing that happened was in Tallinn, in November, in Tallinn, there was a minister meeting where I had the possibility to join the session with AI and security. And what was interesting there was it's actually on minister level that they're discussing AI and security and the consequences of AI in society. And here is some of the interesting things they were saying. What I said before about the Google Assistant, actually Lucas here was talking more about. He said the inability to distinguish between AI and humans has given rise to proposals for a new human right. The right to know whether you are interacting with a human or being an AI. And the ministers also said some interesting stuff, and they were actually quite open about not knowing so much about AI. And one of them said, I'm very impressed by how much everyone seems to know, because I don't understand anything. I've been at the university for several days to get explained to me what AI is. And all I understood was how much I didn't understand. And actually, I think there are a lot of people that have the same feeling. And another minister, the Minister of Finance in Denmark, said, we need to take small step at a time. You can do how many great policies you want, but it's no good if you don't handle such basic things as passwords. Do you think we have passwords in control? I think there are a lot of security persons here, isn't it? No, we don't have passports in control. Actually, security is usually quite bad in many applications. And then we have some other things. It was Håkan Djuphammar that is, I think, his head of research at Ericsson. He said AI is such a powerful tool, such as bomb. You do not need to ban them. You just need to regulate them. And here's another view. Since artificial intelligence is global, we cannot solve the problems that exist by creating new laws. Instead, the authorities respond to beneficial intelligence. So there was a little bit of different view how to handle the risk with intelligence, artificial intelligence. What I try to say was this, that if we have a legislation about AI and security, we really need to ensure that safe development of AI system must mirror existing legislation and method for secure development of IT. We don't need new method that is not in line with old methods. We just need to complement old method for security with AI. So what you could do and what is actually happening now, both in Sweden and in Europe, is defining principles for fundamental principle for development of AI system. And what we are talking about is fairness, ethics, transparency, accountability, and of course cybersecurity. That is what I've been working with before. And there are right now in Denmark a group that are developing methods for risk management in AI. And we also need some kind of verification. I'm not sure exactly how this is going to happen, but we need to start working now. But AI is not only a risk. AI can be used a lot in security also, and in safety. And if we look at cars, for example, do you know what the biggest problems with the car is when it's about safety? Yes? The driver. 80% or 90% of all accidents are because of human errors. So you see the advantages with driverless cars. Another thing is that AI can predict diseases much better than doctors in many cases. This doesn't mean that AI is better than doctors, but AI can help doctors to make better decisions. And something happened with this picture, but you know how much data you are handling today. I know this is a very high-tech audience, isn't it? And AI, you can use AI to find unusual patterns for intrusion detection, for example. But what are the major challenges in AI and security? It's fairness. We'll talk a little bit more about this later, but it's fairness. It's how you can make decisions on fair data. It's also accountability. Oh, sorry. It's also accountability. Then it's who is responsible for the decision, because the AI can't be responsible for its own decisions. And And it's also transparency. It's how the decision is made. And finally, ethics. Ethics is not something new, but now we have to document what we are going to do. And if you're interested in this, you can follow Kate here. She is a professor and posts a lot of interesting things about social implication of AI. So if we talk about fairness, or when AI learns from our prejudices and injustices, here's some examples. This is Thai. It was a Microsoft bot that for a couple of years ago was posted on Twitter or connected to Twitter. And she started with being one of the most nicest girls that have ever been on Twitter. And just, I think this was 14 or 16 hours later, She liked Hitler, hated Jews, and also hated feminists. And the error that occurred here was that she was learning from Twitter. So this is an example of problem of interactions. So one example of interaction problem. Here's another problem. Do you see there's something similar with the persons on these pictures? Yeah, the men. They are 40 plus something. And sorry? Did you say something? No. Men 40 plus and with a special kind of dress code. And this search I did for just a couple of months ago. I did it, I think, for a week ago, and now there is 1 or 2 women here, and I don't know if the reality have changed or if Google have done something with the algorithms. But Google had the same problem with the recruiting ads. And after a while, the better paid jobs were displayed for men and lower paid jobs for women. And so this is a way that society today, in combination with AI, perhaps can make the world a little bit worse than it already had been. So accountability is who is responsible for AI decisions. In some cases, it can be easy. The boat here, Thai, it was Microsoft's boat, and they just shut her down. But who is responsible for the car? Is it the driver, the supplier, the one that has made the algorithms? Someone has to be responsible, otherwise no one wants to use the car. And then we have transparency. How do we know what AI's decisions are based on? And this is one of the trick questions today. Very few algorithms are you can't trace why they made a decision. And what happens here was that Marietje, she made a speech in the European Parliament. And I think it was something about a speech about death penalty and banning, something about death penalty. I don't remember the details. But the YouTube clip on her speech was immediately erased from YouTube. And nobody knew why. So what she said was, when algorithms affect human rights, public values, or public decision-making, we need oversight and transparency. So today, YouTube are censoring us, and is that the way we want it to be? Angela Merkel also have the same point of view. The ways search engines and social networks like Google and Facebook shows what people see online should be made public. So they are all going after transparency. And if you want to read more about this and how you could solve the problem, this is an essay you can download when you come home to your hotel room tonight. It's Why Should I Trust You? So there is some kind of solution of the problems, but it's not implemented today in any project. And ethics. This was my favorite car when I was a teenager. His name was Kit. I'm still waiting for a Kit to be on the market, but unfortunately not. But if we talk about ethics, we now need to make decisions that we did yesterday, but we did it very, very hastily, and we didn't have to document it. For example, in a car accident, should you hit a baby or should you hit a couple on the sidewalk? And the problem is we have to have this difficult discussion now instead of just see what's happening. And the discussion is not that easy because in Sweden or in Europe, we have different values than in US or in China or in Japan. So we have to somehow find a way to coexist with AI and also have some kind of base of ethics. another thing is that if you have a wrong set of goals, if you give the AI a wrong set of goals, it can make a lot of decisions that we don't want or we don't realize can happen. Two types of decision is negative side effects, that it makes it reaches a goal, but there are very bad side effects, and I have to take some examples soon. Or sub-optimation, it reaches a goal, but perhaps it was not in the way that we thought. One example, if this little robot gets the goal to clean up, this is a central station in Stockholm. He could clean it up like we do, but unfortunately this robot don't have the values that we have. And he does it in his own way. So one way is that he cleaned up the central station, and then he put all the garbage in there is a big hole in the middle. And that is quite a negative, that is sub-optimation. So we have a very clean central station, but it's not really nice in the subway. If you have a very negative side effect, it's that the robot suddenly realizes who is doing the mess. And as I write thrillers, I imagine a lot of very disgusting things that this robot can do. So you can have negative side effect or sub-optimations. And if we look into the future, when AI gets smarter than us, and now we are in science fiction, but it's quite interesting to take it as a couple of years in the future. The singularity, most of you, I think, have heard about. Have you? Yeah? The singularity is when a computer or an AI system can develop itself and make itself smarter. And then suddenly we are out of the loop. And what we are just, we are the one that's slowing down the processes. So if an AI suddenly can develop itself, in just a couple of seconds, it reaches much higher intelligence. And then we are completely out of the loop. Another interesting thing to talk about is how do you test something that it's been tested? If you're interested in that, just Google it. There are lots of research papers on it. It's very interesting. And finally, can AI have emotion? I thought, oh no, that's just science fiction. But then I was listening to this guy. He's a Nobel Prize winner in medicine. And he has realized, or he has discovered, in which cell in your brain there is a certain memory. And he can also manipulate it. Fortunately, I have only done this on mice, I hope. But what he said was that soon they will discover patterns in the brain that is caused of different emotions. And perhaps you could use this pattern to implement this in AI. That raises a lot of interesting thoughts. But if you go back to what we were talking about in the beginning, where is AI now? We are talking a lot about ethics, about fairness and stuff like that. AI is in computers. And computers today is not really safe. Of course, not the computers that you are handling, but if on the market or in most of the companies, computers are not that safe, especially in IoT applications or products on the market. This is how much IoT would raise, the number of IoT appliances or connection worldwide will grow until 2025. And the red one is private, is for private persons, and the blue one is for companies. So what we will have is a lot of IoT products that you probably will put a lot of AI sooner or later in. We have Alexa and all other stuff. And today, IoT is not safe or secure. So what I would say is that AI security, it's fairness, accountability, transparency, and ethics that we were talking about at the beginning, but also cybersecurity. It's confidentiality, integrity, and availability. So if you talk about AI security, you can't talk of one of these. You have to talk about all of them. And so I will just make a short summary. What are the risks? One risk is, I'm sorry, there was some Swedish. One risk is that you develop artificial intelligence that is for defense reasons and stuff, that is actually military appliance, and that does things that it's supposed to do, but not in the way you want to. Another risk is unaware development of harmful artificial intelligence. We have also a risk group that it's manipulated intelligence, and that it's, as I talked about Tay before, she's manipulated by Twitter, but this is also a way to manipulate stop signs for cars. If a driverless car read stop sign with these small dots on, we don't see really the difference, but if they read it, they think it's 45, the speed limit is 45. Another risk group is bias and other data-driven problems. And finally, cybersecurity. And that was about what I was supposed to say. If you want to talk more with me, I'm on Twitter and I'm on LinkedIn. It's just add me.
So thank you, Åsa. So we're running a bit tight for time, so we're going to bring on the next speaker. Thank you very much. So the second speaker of the last session is Daniel Sörlöv from Microsoft. He is a technical expert and technology advisor working with mainly security, compliance, and trust in public and private cloud. So please join me in welcoming Daniel to the stage. Thank you.
Hello, everyone. Introducing oneself as an expert in this room is, I was here this morning, so I'm pretty humble at the moment. But let's hope I have something interesting to bring to the table anyway. This is the first time that Microsoft, as I know it, have appeared at Netnod meetings and stuff like this, because we have been quite a closed company. We haven't been as open and about and talking about ourselves. So let's see if we can start some kind of trend here in at least this setting and with this stuff. I've been around quite a while on the internet. That's why some of my pictures are going to be very blurry and pixeled, because they are old and resolutions wasn't that great a couple of years ago. So when I talk about the things I do in my everyday life at the best company in the world from my perspective, because we do some really amazing stuff, which I hope to give you part of today, I bring up this picture. How many have seen it? I love it. It's fantastic. I always use it when I do the descriptions of internet security and how people do, well, we'll install the firewall, correct? It's this shiny, beautiful gate. No one will get through and steal our barbecue up at the house, right? No one will get through the gate. That's true, but they'll just jump the hedge, right? Or climb the, yeah. There's so many things to discuss here about this picture. But I like the analogy. And the people that I meet when I have my discussions, I'm a TSP, which is a technical solutions professional. I work with information security. So a lot of regulations and how we do transfers and stuff like that. And I use this just to explain to people. We can solve this, right? You know what is this? How many have seen this picture before I explain the magic with the picture? Yeah, some of you? Because we can lock stuff down, and if we do, well, users will tend to find a way around that. Again, a brilliant example of internet security, right? Wi-Fi password 1234, stuff like that. This is because what we do, what you guys do, what I do, is not what people actually use. They're using the internet, for instance, or the networks to do what they are supposed to do, not using the internet in itself is not an objective. And users are trying to do stuff in the way that we tell them to. If we tell them to be secure, they are really trying to be secure in the best way that they possibly can imagine security. I mean, it is an approved lock. So no one can have any complaints about this, right? And we don't need to worry about users, right? We have monitoring. We see everything that they do. Again, I love these pictures because they are so simple and they describe. This is a SIEM system for me. This is the perfect illustration. We got it. It logs everything. But we don't know what's happening anyway because we don't look at it. So let me go on a short time journey a couple of years back. We're going to land here. You see the time machine. I'm from Microsoft, so I know the animation stuff with PowerPoint. We landed in a time long ago. How many years ago? What do you think? 19, 18, something? 1915. I'm going to go with that almost. I'm going to go with 1919 because then the math will be much simpler. So we're here. We're looking at the main street internet. They're looking at the intranet here, looking at the menu, what's happening tomorrow, what's happening today, what's the restaurant serving for food. They're looking at the carriage and horse 1.0. They've heard and they read about it in the news that there's a 2.0 coming out with a windshield. That's going to change stuff, right? So 1919. They had electric cars. Yeah, they actually did. You ruined my presentation. Can't do that. But we all see what they're doing. So if we go 100 years in the future, we land today, downtown somewhere. How do you think this looks today? Well, it looks exactly the same, right? We're still checking that intranet. We're still fantasizing about that Ford Focus or whatever it says. It's still the same things that we do time after time after time. These are challenges. So what I'm translating this into is challenges, because we think that so much has happened because our perspective on things have changed, but we're still doing the same old things. We're still building the same old networks. We're still doing the same old SMTP. I mean, why can't we kill that protocol? Please. I mean, it's been around too long, but why aren't we doing that? Oh, because we've done something else. We've replaced the newspaper. So that's why everything is different, because we have smartphones now, right? But it's still as broken. We're still fantasizing about horse 2.0 here, but the horses are iron horses instead. So we haven't really developed or changed that much. A couple of years ago, we had a new president on Microsoft. You all remember the clip with our old Ballmer developer, right? I'm not going to do that on stage because he's got more energy than I do. So it's not going to look right. But you remember that. But then we got Satya Nadella, who is a person that have changed our company and our perspectives in a way that we are actually looking at how and what we are doing instead of just changing those phones to something else. So it's a matter of perspectives, right? I stole this picture somewhere. It's open source. It's in the notes, and yeah, you know, the whole thing. But it's a perspective thing. So I want you to have a broad perspective of why we are doing stuff. It's not just because it's cool. There is actually reasoning behind every little decision. And I think that's something that we need to take with us. I'm going to go into some things that have changed around us. in the world. If you remember that high street picture, some things that have changed and the demands that they are requiring from us. The first, for me, being working with information security, GDPR. That's changed a lot, right? I just stole this marketing slide. I don't know almost what's on it, but GDPR changed a lot of stuff. Even my dentist, the other day, I called them to cancel my appointment. Oh, do you have your bank ID? It's like a phone authentication thing. I'm like, why? Well, I can't know that you are you without that. We need that for GDPR reasons. I'm like, no, you don't. Really, no, you don't. But she insisted, and I mean, it was good to be authenticated and stuff like that, but it's so misunderstood. But this had made a huge impact on everything from networking to, I'm talking daily with companies requiring to have TLS during transfers of data, not on the actual data, not on the connection, but on the fiber. And it's kind of, you can't do that, but not in the way that you want to do it, but we have other means of doing that. So that's one thing. Then we have this beautiful thing. You all should know what it is about, right? Infrastructure security for what's called the essential services, public communication networks. It requires to handle security incidents. We can't just not say anything about them. These are two big ones here in Sweden that we are talking a huge amount about all the time. But it's not only these two. We have so many regulations that have come in now. And this is quite new, at least for the Nordics, where we haven't been that comfortable having laws and regulations and checklists for everything. When we're talking about daily, how do we evaluate information security? How do we evaluate physical security? Oh, we go to some American standard or some, because there aren't really that much in the public here. There are some standards that we use from a technical perspective, but that's not really what I'm after here. So a lot of things are changing. Okay, I'm the second last person between you and the burgers, so I'm really trying to get this done as quickly as possible. But another quiz, who's this? Darwin, yeah. He's known for this quote, digital Darwinism. Okay, not perhaps known for that, perhaps he didn't say that at all, but kind of digital Darwinism. When you need to change, and if you don't, you're out, basically. I remembered I had to check the year actually, in 2006 I was on stage at TechEd, which is a Microsoft event. I was talking IPv6. That was the first year I talked about IPv6 at Microsoft because we just introduced it into the stack. It was official. We could do IPv6. Woohoo! Do you know how many people were in the room? 2. One of them didn't know that it was an IPv6 session. He thought it was deploying a Windows. So he left. So it was quite an interactive session. So I did that a couple of years. So when we reached 2014, I think, that was when I did my last of the IPv6 presentation. Actually, it was kind of the same presentation all years because no one listened, no one wanted to do anything. And kind of still is that, yeah, you got the sticker as well. So, you know. But there are starting to happening things with IPv6. Just to make one example of digital Darwinism, we have to be there, we have to do it, otherwise other people are going to do it, and they're going to change that. So I wanted to talk a bit about our networks and why we do stuff. This is why we evolve. This is why we see people and what they are doing in their environments, and that's why we're building stuff. And what we're building is one of the coolest networks in the world. I'm not going to say largest because then someone is going to debate that and the session is going to run over and stuff like that. But it's a large network. It's a really, really big network. We have 54 Azure regions A region for us is at least 2 data centers, at least. So a lot of data centers. We have 100K miles of subsea cable, WAN fibers. We own it. We perhaps share the physical cable with someone. We don't do that. That's not Microsoft. But we're owning the actual transfer. We're owning the end stations and stuff like that. We have 140 edge sites where we meet customers and partners with peering. That's the public number that I can talk about. There's a load more, and some of you in the room, you are part of that network as well. We have some express route partners, which actually is getting our customers' traffic into this. So why are we investing so much in building this infrastructure? Because there is a public internet. Why can't you just use that as everyone else? Well, it's not good enough, frankly, because we cannot control the quality as far as we want. We want to have just that last mile. We would love to have our customers directly into our network, just to control how everything flows. We need to make sure that if someone watches a video, that doesn't get stopped by an email or whatever, and we need to control the routings. I mean, we're talking about signed routes. How many years have we been talking about that? Anything happen there? No? Can do still false advertisements and stuff like that, right? So that's why we are starting to build this, and we have done some amazing leaps. One of the coolest things, from my perspective, I built networks once, is this. Oh yeah, that's kind of the first presentation of the day, right? Yeah. I don't want to be that guy, but he stole my whole thing. So. No, but we're talking about developing actually the hardware to make sure that we have control over the most minute parts of the network, to make sure that we can control the quality for our customers from edge to edge, basically. It doesn't mean that I'm announcing that Microsoft will sell ISP services, that we'll be an access provider or anything like that. We'll just make sure that our customers get to our data center as quickly as possible, as reliably as possible. If I continue, these are codename Madison, the small SFPs that are going to get stuck into our equipment. And the reason for us having them is just to make sure that we can remove a lot of hardware. We want to minimize how much hardware, we want to minimize how much management, we want to minimize how much energy that is consumed to make this happen. We're talking about 1.6 petabytes of inter-data center switching. That's how we do our in-between data centers. I still find that number quite mind-boggling in many ways. 1.6 petabytes. That's, yeah, it beats my first modem was a 2400 baud modem. Yeah, that's a couple of years ago. We're talking about what we call yesterday's solutions, where we replaced a lot of stuff. We went up to 100 Gs, PAM4. That's one step, right? We got that this morning, so I'm not going to go through that. What we're seeing is the next step, which is the 400 specs. Oh, we went through that also this morning. Yeah. You know, you sent in the slides in advance, so I thought I'd get some heads up if anyone talked about my stuff, but I'm not bitter. Okay, but it's really cool stuff, and we're driving it because we need it, because we actually really need it to build the amount of networks that we're doing. We're in place upgrading our network. Before we had an ingress and an egress point to our data centers, that was it. Now we're actually building a network in between our data centers and our peering points. just to make sure. We're doing this with switching equipment. We couldn't really find what we were looking for, so we went open sourced. We are working with the community, driving this. This is why we did this was to make sure that we did not have a lot of components in the hardware that we didn't need. We didn't need support for feature X, Y, and Z, so why have them there? The code just breaks things. It adds an amount of bugs. It adds how much the power, the utilization, the hardware itself, it becomes more efficient the less and more specialized it is. So that's why. How many have looked at Sonic? Tried it, using it? I mean, come on, guys. And girls. Oh, okay. It's really cool stuff. Look at it. It's on GitHub. Sonic is a network OS that really brings in what we needed in those data centers. And one of the things that we understand is that we need to make changes while stuff is up and running. I remember when I started in this business, it wasn't unusual to have, we'll have a 6-hour service window because we're changing some of the routers, we're doing some stuff, and so it's going to be 6 hours downtime. You can't do that today because businesses really require everything to be up all the time. So in Sonic, you can do a reboot process that is really, really quick, and it utilizes actually the ASIC. We're going down to the actual control, the chips, talking to them, and we're just reloading what changed. We're not restarting, we're not, and that architecture is really, really useful for those intra-regional networks where we can't have any downtime at all, basically. So we're talking about sub-second data blocks instead of long times while we reload everything, so we're separating things up. So I encourage you to look at the Sonic stuff. Our data centers are built around regional availability zones. This is something taken out of a screenshot out of the internal monitoring system. I think it's very clear, all the nodes and their connection points. Well, the thing I wanted to show is that it's a really complex mess of connections and stuff that needs to be controlled when we're talking about controlling the network. For that, we have taken actually a lot of open source stuff, brought that into a fantastic process that's open. You can look at it and how we have done it. It's where we take every network thing that we need to do, every change, we pull that in, we automate all the testing, because we realize that AI, automation, is the way to go forward, because we can't manage. I mean, no one of us could ever keep that whole map in our heads. Networks are getting bigger, faster, higher requirements, demanding more robustness, and we cannot really do that. So we need those machines. Let's hope they're not turning against us anytime soon. They could do some evil stuff. One of the big things that we have noticed happening is different kinds of attack in writing, where and attacks, it's kind of a strong word here to use, actually. What I'm perhaps talking about is mistakes. You know, doing the wrong announcement on an interface somewhere could lead to traffic being redirected. So we're continuously monitoring all the changes and actually blocking those that we don't find suitable for any particular reason. We want to maintain traffic flow, and if traffic starts to flow in a very strange manner, we'll actually call up whoever it is and make sure that it's a correct thing before we actually let that happen. We have a huge footprint in traffic, so that makes that intelligence really much more relevant. It can take decisions for us if it's a good or bad thing that just happened. Is it a normal failover scenario, or in what way that would affect us? It's pretty small amount, though, of all the hijacks that we see that actually leads to something being blocked or taken another way. We do not always honor every routing instruction because we want to keep traffic in our network. So kind of keeping everything inside our network as long as it's humanly possible, or it's not human because it's machines, but you understand what I mean. Just keeping that traffic inside our networks to be able to control it, to make sure that evil stuff doesn't happen on the way. We used a lot of data sources for this, 1,000 Eyes things as well. Anyone seen this picture? Yeah? So you know what I'm going to talk about? Yeah? What is it?
Transatlantic cable.
Transatlantic cable, yeah. It's a cool thing. It's a really cool thing. Maria, which is a little thin cable stretching from Bilbao and landing in the US. I can't ever remember where in the US, so I'm not going to pretend. Virginia Beach. It says on the slide. And I was informed by my colleague who got me these slides that said, oh, the bottom one is going to really impress people that work in optics because they're going to see that it's clean signal. And I'm like, oh yeah, that looks clean. Do you agree? Yeah, I don't know, but it's impressive. What I think is really impressive here is that it's really decoupled the different things that we can do. We can transform, we can change, we did some amazing stuff, and we got some really good throughput in experiment just a short while ago. And if you want to see that and hear that, I think there was some recordings from the OFC, OFC, right? Talking about more about that. Last thing I wanted to talk about was the architecture that we use for connecting our customers, where we actually, if you look at this picture and you have the internet, we're not touching so much over there. The edge, we had that. Edge is where traffic goes in and out of the network. We had that for a long time. And we had our data centers. But what we've done is the part in between, which we call a region, and we did that whilst everything was up and running. We did no reroutes. So this is how we're moving ahead and building that internet that needs to be there for our customers. I mean, if you're on Office 365 and you need access to your email, well, we need to make sure that that works as far as possibly can. So that's why we are building stuff, because we cannot really trust that what's out there, because there are no guarantees on the internet. So that's why we're building stuff. That's why we're driving and opening up. And hopefully you have noted that we are more open. We're actually talking about the stuff that we're doing. We are sharing. And just being here is one of those things that we haven't been able to do locally before. So I think that's really a great thing. And with that, thank you very much for listening to me a couple of minutes. I'll be here, so if you have any questions, please let me know. Thank you very much.
Perfectly timed. Thank you very much, Daniel.
Thank you.
So, for the last speaker today, will be Fredrik Svedberg. He's the CEO of Logtrade, an entrepreneur with more than 30 years of experience within the software industry, and he's going to be speaking about the Internet of Logistics. So please join me in welcoming Fredrik to the stage.
Hi. It's very nice to be the last one between the hamburger. But I'm here today not to educate you in anything. How many in here understands how internet is working? Thank you. That's why I'm here. I need help. I have this big idea. It's a very big idea. I'm going to change everything, and I need your help because I'm going to do the complete physical world into internet. Why do I do that? First of all, the trends in the market. You can read it here. I had this together with Stanford Research Institute for many years, but now Harvard says this and everybody believes in it. When the financial guys comes in, they believe in it. Everything, people, things will move around. We will not have schools, workplaces, or maybe even family homes. We will move around. It's a complete movement of everything. How do we interact with things who is moving? How do we interact with people who is moving? And how do we do business in a world where everything is moving? Yeah, it's internet. The next thing, everybody is looking to these young girls, 15 years to the first child. Those are the new market. No. This is the new market. How will we build our houses? How will we get our food? How will we educate ourselves? How will the farming work in the future? How should we do this if we move to Mars? This is what we are working on. We are not caring about how you get your shoes. I don't care. It's not important. This is important. So, I will correct the numbers we had before with 1919. It was actually in this period, 1901 to 1930, where we had one car to the left and one horse to the right. The tipping point, and this is the most important thing for you to know, the tipping point was 6 to 9 months. A period of 6 to 9 months moved away the horses and put in the cars. Up here to the left, you see a hole. That was for horse shit. That was the biggest investment they did in the history of New York for the infrastructure, and that's why they were the first one with a subsystem. Because they needed to have it when the cars came. And that's actually Bill Gates' grandfather, because he took the logo there from. I don't know why. But what we are doing is that my Logtrade and my partners, I will come back to, we are now trying to understand what will happen. And we have done it the most things in the world right now. We are actually going for Amazon. I don't care about Tesco. I don't care about the structure. I go for Amazon. I go for Jeff. Jeff did Amazon in 95. I did Bocuse in 96. I go for Jeff. World's biggest company, I go for them. Together with Ericsson, together with IBM, together with Sony, together with Here and Stanford. I go for Jeff. Next thing, food will be used. We can't throw away food. We throw away like 50-60% of all food produced. In the US, we use 25% of all the foods for our pets. It's not sustainable. I will change the shopping malls into logistic centers. Jeff can be in Eskilstuna. I'm in Sickla. Now, I'm in Sickla now. You can go there. It's called Leveriet. I will not have trucks going around on the roads being half empty. We are on that spot. We are connecting pallets, so pallets itself can be an Amazon Go store, and it's working. We are selling things in those stuff now, and we will throw ketchup on people before they know that they needed ketchup, because no one knows that they need ketchup, and they are moving around, so I will try to hit them. And I will go for the washing machine ordering its own stuff, and I send my 2 colleagues, the young ones, to China to understand, do we need to be communists? Maybe. And then I get the defense coming out saying that Fredrik is something on here and this will change everything. And that's the Minister of Defense saying this on LinkedIn. So we have something here, so please help me. I don't know how to solve this, but we will do it. And I am selling soil in a parking house in Norrköping directly without having any stores sending the money to the owners of the soil right now. We started that last week. And yesterday we launched the first project where we'll have an autonomous self-learning robot handling these small service centers with Fredrik Svedberg from Linköping. That was launched yesterday. What I will launch tomorrow? Yeah, I will fly drones in Västervik. Now, I go for Jeff. So this is where it all starts. A lot of products. Anybody here done any e-commerce sometimes? Have you bought anything on the net? Okay. You know, it starts here. It's a typical factory. This could be a bakery, a factory, a shoe factory, just a warehouse. You see this warehouse all over? It starts there. Your package starts here. Now let's take this package and see what happens. It goes through 4 different processes. Here is before you have decided what to do. Here's when we ship it to you, and then we check if you are happy. No one is happy. Everybody's angry on PostNord. And then we try to do some data analysis and go back and do it better tomorrow. But we haven't figured out how to do it. And just for you to know, we need 5 more PostNords in Sweden the coming 3 years. 5 more. Do you want that? No. No one wants that. So we have to rechange. I'm training every day. I do 3 million transactions every 24 hours. So I know about you. If you buy a greenhouse in a combination with some seeds, then I should handle you to the police probably. Or if you buy shoes and food, yeah, you're training and eating. That's good. We know that. We do combinations every day. But we are not Facebook. Actually, my COO, Sarah, you saw in the picture of China, she has a T-shirt saying, I'm not Shannon. We're going for them too. Here how you do it today. All these guys, you know, the farmers, blah, 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 you heard them before. No one of these guys have any predictive capabilities. How many here has bought the Christmas gifts for next year? Great, I want you. Is anyone in here not thinking, do Christmas come next year? Have you changed to your summer tires? Do you change your winter tires in September because winter is coming, or are you at the first day where it snows at the garage? We don't have any predictive capabilities, because Stanford says to me, if we should have the predictive capabilities as I want them to have it, we will kill ourselves. Sorry, it's a math. So, by not having that, we need these big, big warehouses here. They're very ugly too, don't you think so? They're really ugly, and no one wants to work there because they have no windows. It's really ridiculous to build a thing. No one wants to be there. We don't want to look at it, but it's there. Why? Because we don't know when the ketchup is running out. You're sitting there at home, maybe the ketchup will run out now. No, one more dinner, and then the latest, I want a drone. We can't do drones with ketchup. It's not sustainable for the society. So what we want to do here is to figure out when you need ketchup, produce the ketchup and move it very, very slowly to you, and then suddenly you say, I don't have any ketchup. Oh, it's here. 5 o'clock, you're going out. It will not happen now, sorry for that. Coming out the door saying, it would be very good with a gin and tonic, it's there. Whoa, that's a nice one. Shouldn't I have new shoes? They are here. At the gym, actually, because it's where you're supposed to use them. You get the point here. This is just internet for physical things. A little bit more tricky for me to move them around than the email and FTPs, but yeah, it's the same thing. Together with Ericsson, we actually opened up this standard, creating what we call the Internet of Logistics standard. So now it's an open source standard for everybody to use. Everybody can go in here, even Jeff. But he won't, because no one is owning the data then. What we did here was opening a standard like Ericsson has done with the GSM standard, the Bluetooth standard, and now we do the Internet of Logistics standard. So their part in this project is actually, we have the standard, and we moved it over to a very amount, 50, I think, different organizations, like IATA handling the airlines, and other handling the ships, and the third one handling the drones, whatever they will be called, I don't know. the drone community. And then we created a technical layer where we can connect everybody with simple REST APIs or whatever today. Logtrade is actually a command and control center for this. Ericsson is the data securement level for this. And then we connect everything. We connect trucks and cars and packages and people and cats and dogs and whatever. And everything in the world now is a URI. You know URI? Everything in the world is URI. And another thing here, there are no products anymore. Everything is a package. Ta-da! This chair is a package. This computer is a package. 2 computers exactly the same, that's also a package. With 2 computers exactly the same. A computer and a chair together, that's a fruit bowl, but a package. So we skip the products, we make everything a package. You know packages, everybody knows packages working with internet. So now everything in the world is a package. What can we do with a package? Move it, charge for it, store it, combine it, optimize it. It's a package. Next thing, let's have those packages accessible through the internet. Of course, the standard is there. You find something on the floor, you just went to it and say, hey, I'm ketchup, what do you want to do? I'm $1, I buy you. Grab me and go. That's an Amazon Go for real. Or I say, I don't want to buy you and carry you from here, but I want you tomorrow. Okay, I'll be there. E-commerce physical. Or the ketchup says, hey, are you going home, for instance? Yeah. If you carry me to your neighbor, I give you $1. That's a package for real. This we're doing now, not then. We are profitable. A good idea with a profitable company. Have you heard about that? Google last time. This is our friends. I don't need a gun. Maybe, but not right now. They are protecting us. We have the Watson Center for working with the here for combining all the places with attributes. And we work with this. Now, let's look in how to do Internet of Everything Physical. This is the future of delivery places. This is places where cars will going around, being a hotel room sometimes, a hairdresser, or blah, blah, blah. This is where we can put things in your trunk before you come and grab the car in your carpool. We can load cars in the night. We can load food in the night. Everything here will be exactly automated. But we have places today, when you're checking in with booking or hotels on your hotel room, you can have your clothes there and just leave the clothes you don't want. That's very convenient. Men, I see a lot of men in this room, are not buying trousers on the net. We're buying everything else, but just trousers is not the product for the net for men. We don't know why yet, but let's try to bring them to the hotel. Maybe we buy trousers. I don't know. The gym is probably one of the places where you will be. I thought that until I met the founder of Peloton in USA. That's a very, very new product, a bicycle that costs like a horse's bed. And it's very successful, and that actually moves the gym into your garage or your home. So maybe the gym isn't a place either, I don't know, but I thought so. Dog take caring center. You know from the statistics that there are more people getting the dog in time than the kids. Very interesting statistics. The Alibaba store, do you know the Alibaba store concept? I move around. I'm very interested in one area. I open an area for that store. And people in that area comes and we nerd down to things together. That's new retail, funny people, just my type of people, you know. I have this store, it's always myself there. And then I have this hairdresser and so on. This is the other thing we do. We try to look, where are trucks going around? This is also working. It's not a future thinking. Where are trucks going around? The red one up there is filled. The green one down here has place. Then I can put something out here saying, I want to go to Oslo. And the truck says, oh, I can take you to Halmstad in this case. Okay, it's a hitchhiker. So I'm hitchhiking myself around as a pallet or a package. The other thing we're doing is actually working with these products now. Paint on your wall on the house. You buy a new house, you have guarantee for 2 years. After 7 years, you should repaint it. And you do that after 12 years because you don't have any predictive capabilities. So after 12 years, you say, I have to paint my house. And then you start calling around to the painter saying, "Can you paint my house?" And they say, "What paint is it? I don't know. Do you have all the equipment?" No. So it's a mess. So it's better that the paint actually says, "I need to be repainted on this wall," and order the package, and the package order the painter. You get it? So what we do now is actually creating a boss. So the package is actually going to say, "I want to be moved, I want to be recycled, I want to be painted, I want to be mounted." So no one working on a building construction site in the future will have any planning, because they are lousy on the planning. You know, they have like 18 months of predictive data, and still they don't know where anything is and what to do. So they take away the calendars, saying, "Go there tomorrow, stand on this place, and a package will come and say what you should do." This is exactly what we need to do if we should build a house with a robot. So we're just converting people to robots before the robots can do it. Because then it's much easier to build a robot. You get it? No one will put the wrong medicine in the wrong person anymore, because the system will know it's the wrong medicine with the wrong person. You should change either of them. This is not so hard, it's just code. You get it? Shoot.
So you have a URI that had Ericsson.net. They don't run DNSSEC. How are you going to secure this?
It's up for Ericsson in this case. I don't know. It's a good question. I take it back with them. I promise. I asked for help. Please help me with this then. So that's good. The next thing I will do here is to have everything to be everything, as it is on internet. Because what's the difference between actually an email, an FTP, or a www or whatever? It's just code in different forms. We can say that the code is different things also, but what we're trying to do here is actually that actually in the physical world, we have something to be shipped. That's from a shipper, that's from a bakery or a factory, going to a location with a capacity. So if I want that bottle, you will be the shipper, I go down and bring it, I'm the capacity, and I put it here, this is the place. And this goes around and around and around. And things doesn't disappear until you ate it, mounted it, or recycled it. Until then, things are there. So, to prove this, I'm baking bread. Because with bread, I have 12, 24, 48-hour cycle for all this I said. Because bread gets old. If I do this with building material, I need to be 140 years old to see the complete process working, and probably I will not be that. So I did bakery. This is the bakery. This is actually real pictures from Twitter's head office down there. The Blue Bottle Cafe. So I go with its bread trucks around in San Francisco, delivering bread, trying to learn how will the future looks when bread is delivered with robots. Right now. This is how it will look. Up to the left, you have the bakery. There are 2 million bakeries in the US. That's a hell of a lot of bakeries. Connect all those bakeries, will be the biggest bakery in the world, but they have never met. That's internet. Then you don't need Nestle and those guys. And Whole Food, we killed them, took the bread. Next thing we do is actually to replace the bread trucks with these small things going themselves. We have autonomous things going around in Santa Clara with Ericsson right now, around 100 different types. Flying, going inside, going in trucks, blah, blah, blah. Ordering an Uber, ordering a Lyft. I want a Lyft. Who are you? I'm Brad. Brad ordering a Lyft. Yeah, I want to be in the trunk. Why not? And then we move this bread to the first A customer. Those customers paying the price I want, expect the quality I'm saying, and it should be in time. For bread, it's typically like 0 to 6 hours after the bread is produced. That's the A customer. That's Blue Bottle, Twitter head office, Google, and House head office, I think that is, in Palo Alto. After that, the bread says, hey, I want a new Uber. Hey, who are you? I'm Brad. Okay, where do you want to go, Brad? I want to go into Stanford. Why? I'm going to sell myself to half price. So I'm going into Stanford saying, hey guys, you students, you don't have money. I'm still good bread. Buy me for half price. They do. After that, the bread say, I take a Lyft now because Uber is not so very kind to bread. So I take the Lyft now. And the Lyft is coming saying, where do you want to go, Brad? I want to go to this charity organization because I'm going to give them my bread, because then the A customers tomorrow will pay even more because I'm a good bread. And when even the charity organizations don't want me, I say, hey, maybe I don't take Lyft or Uber, give me a tractor. I want to go to the pig farm because I will not create waste, because on Mars I can't create waste because there's no window to put it out. So I have to be something. So I be food for pigs. And then I go back to the factory saying, hey, do you have new bread for me to work on? And then we connect these bread selling things together, 10,000 here, 100,000 in France, and then they learn each other. Today it's sunny, go with the bread to the football game. Today it's raining, let's go with the bread directly to charity. And so on and so on. That's the Tesla model. We actually have the same team there. So now we're learning bread how to sell to us. When we have done that with bread, we can do the ketchup. So ketchup and bread is the future food. And salad, and tomatoes, and oranges. And this is where we train Watson, for instance, in. And this means that all the locations need a definition like we have on the internet. So a location need in the future, this afternoon, maybe tomorrow, actually knowing, should I let this guy in because he's a robot carrying something very bad, or is it good? Should I open? Should I move? Do I dare to go in there? This we need to solve now because it's just robots entering places and we don't want to hurt people, drowning them in ketchup. Because if you think that the robots, AI, will kill us with guns, it's completely wrong. They will kill us with ketchup. Huge amount. You're super surprised. Complete Manhattan is drowned in ketchup. What happened? I don't know. It was something wrong in the algorithm. The cheapest war in history. The other thing we have in the gig economy here is actually, is this the paint for this wall? Is this the clothes for this place? Sorry, it's a free picture. And is this the sofa that I should place here? And should this salt be in this dishwasher? All of this need to be solved. This is what I'm asking you for. We need a lot of methods, we need a lot of security, and we need a lot of things to think about because people will use this thing in order to try to do things with the ketchup. That's why I'm here. Help me. This I already solved. Second opinion, physical blockchain, call it whatever, of having a package opening a smart lock. So in this case, someone is buying something, shoes, I say them, because they are those girls, 15 to first kids, buying something, going with DHL to your home, and we need to open the smart lock. Instead of having these codes out, often in paper structure in the truck, so if you want the codes, you can get them there. It's better to send a copy of everything happening to, in this case, SOS Alarm or a 911 operator. And when the DHL guys actually ends up at your house, the lock is asking, should he be here now with these shoes? And they say, yes, open. At the same time, this guy or girl can have help if they find someone being ill or a window being broken. So they are actually now being Securitas also. Because Securitas is going around today with just a scanner and no packages, and now we have someone else going around with a scanner and a package. And if a lamp is broken, we can actually have this person to fix it, technical home taking care, when they are there. And if it's a threat to them, that's the most common today, young girl having a delivery, coming into an apartment, and a guy is waiting, do you want coffee? Yeah, then they have an alarm button on the other way. So we are securing up this method around the physical internet with all these methods. So I'm turning everything around. I will change the world and I will kick ass with Amazon. So please help me. I have shitloads of customer applications out there and 3 million transactions every day, so we can start working whenever. So just an introduction to what I'm trying to do. Thank you very much for listening. Thank you very much for having me here. I will also have the hamburger, so I stop now. Thank you.
Do you want to take any questions? Or?
Yeah, sure.
Just very quickly, is any questions for Fredrik? Or did he say it all? Okay, we'll see you tonight for burgers then.
Yeah, sure.
Okay, can you thank one more time for Fredrik?
Yeah.
Thank you.
Thank you.
So that's the last speaker of the first day of the Netnod meeting. Buses will leave at 5:15 to take us to the social. Please don't forget to bring your badges. And thanks to the speakers and thanks to you for a very great first day. Thank you very much. See you later. Bye.